is a first chapter, units and measurements. Before going into units and measurements, let me tell you what is the use of units and measurements. What is the use? See, we are dealing with a branch of science that is called physics. Physics is the actually study of matter and energy and their interaction. So while talking to the interaction, we must know all the physical quantities involved in our while dealing with matter or energy or their interaction. Let me explain you what is the need of a physical quantity. See, physics is the study to matter, energy or their interaction, to find out some laws. Yes, so to express the laws of the nature, express the laws related to both matter, energy and their interaction, we need some parameters, and these are the parameters. Actually, basing on that parameters, we can express the laws of nature, and they are called physical quantity or physical quantities. Clear? Example, your mass, length, time, temperature, so many quantities, energy, momentum, impulse, so many physical quantities are there. Now broadly, the physical quantities, they are divided into two groups, fundamental and derived quantity. Why I am talking? Because before going into units and measurements, we must be clear about physical quantity, because these units and measurements is related to your physical quantities. What? Measurement of a physical quantity by some units. Later on I will be coming to that topic. Let me explain you the physical quantity. Already told. Then this physical quantity is divided into two groups. One is called your fundamental physical quantity and the second one is your derived physical quantity. Why fundamental? Because it's not like that all the physical quantity come to your physics from the day one when people have started learning physics. It's not like that. But it depends on our requirement during that point of time. So many physical quantities are there. They come one by one according to our uses and according to our research, time and again our development. So on our development also the physical quantities have evolved, and for our better understanding we have defined these physical quantities. Clear? So why fundamental? Because these are fundamental quantities of that. They are suitably chosen. Suppose there are n number of physical quantities known to us, and we have defined to know the nature in a better way. So out of all the physical quantities, these 7 fundamental quantities are suitably chosen. They have chosen in such a way that most of the physical quantities, they are independent of each other. Like let me give example, like mass and length, they are completely independent. Clear? Similarly, time and temperature, they are completely independent. That's why they have chosen, and all the quantities, they are called your fundamental physical quantities. And later on, some quantities are there, they are dependent on each other. Clear? And let me explain you the fundamental. There are 7 fundamental quantities are there. Mass, length, time, thermodynamic temperature, electric current, amount of substance, luminous intensity. Almost they are independent of each other because their branches are different, but we can link them. And second group of quantities, they are called derived. Why derived? Because using these either fundamental quantities or other derived quantities, these physical quantities can be derived. Like I took the example, let's take the example of speed. Speed is equal to distance by time. Distance, it is related to your length, and it is time. Distance by time is your speed. where speed is a derived quantity by taking two fundamental quantities. Clear? Now comes to another example, force. Force is the product of mass into acceleration. Mass is a fundamental quantity, whereas acceleration is another derived quantity. Why? Because acceleration is what? Acceleration is what? Change in velocity by time. So velocity by time will give you the acceleration. Velocity is again what? A derived quantity, and your one fundamental multiplied with the derived, again we are getting another derived quantity. So that's why this group, they are coming under derived quantity. Now let us come to your measurement. Let us come to the measurement. See, it's not like that we will know the physical quantities and we cannot use them. We use them. Clear? So any physical quantity, they can be known in two ways. One, what is that quantity? That is called qualitative. Qualitatively we must know. And again, while using them in our a scientific study, we need to measure these quantities. Clear? To have a measurement. Why? Because without measurement we cannot use them. Clear? So for that, this measurement is necessary here. Then comes to your units. Then what? We must measure the quantity for our use. So for any measurement, for any measured physical quantity, we can express our result like this. This is a measured quantity. It is P is equal to N into U. Any measured quantity can be expressed in this way. Here P is a physical quantity here, measured physical quantity, N into U. One example I have given, suppose there is a small elephant, you are measuring the weight of it, or the mass of it. Mass of the elephant, let's say we found it is 2500 kg. Here N corresponds to your 2500, that is called a numerical value of your measurement, and this kg means your 1 kg means 2500 kg is equal to, we can write 2500 into 1 kg. So 1 kg is the standard unit used here. So let us come to this standard unit. This is the most important part here. So what is the standard unit? Let me tell you an example. Suppose someone will ask you, just measure the length of this room. You are going to measure the length of the room. Suppose there are 10 students of different height, 10 students they are there. There is a very small student, there is a very big student, tall student. So all of them, they are trying to measure the length of this room. They don't have any kind of instruments, so they try to measure the length of this room by this span of this length, from this tip to this elbow. The length, they have just applied on the floor, they put it and they just measure the length of the room. See, this is the length of the room, the span of the room is fixed. But the span of this length is not fixed for all the people. Clear? So the measurement will definitely differ. Someone will say the length of this room may be 3 arm length. Some may say 4 arm length. Some may say 10 arm length. So the logic is this, though all the measurements, all of them, they have measured it correctly, but since the value is differ from person to person, so we can say this is not a standard measurement. Clear? So what is the quality of a standard unit? These are the qualities of a standard unit. What are the qualities? First of all, they must be well defined and convenient in size. Well defined and convenient in size. The example what I have given, that is not well defined, because the span of this length is not fixed for all the people. So they are not a well defined unit, and it is not convenient in size also. It is not convenient. Clear? Again, let me give you the example of a convenient insight. Suppose you want to measure the mass. Suppose there is a big rock. You will take that the weight mass of the rock to be your convenient unit or standard unit. Is it convenient to take the rock and all the time you are comparing the mass of the rock with the quantity you want to measure? So all the time it is not convenient. So it should be it must be well defined and convenient in size. Right? Then it must be universally accepted. Got? Suppose I will devise 1 unit. Some other part of the country they will devise 1 unit, and there is no link between us. Then it will be very difficult for us to they know what is my quantity, measured quantity, and what is that quantity. That they may differ. That's why it must be universally accepted. There must be a system under which we must follow a rule to measure all the physical quantities involved in our physical measurement. It must be easily reproducible. Clear? It must be well defined, and we can, for our betterment, for our better use, wherever we want, we can again make that quantity easy for us. So it can be easily reproducible. Should not be affected by external conditions like pressure, temperature, and any external conditions should not affect the value of the quantity or unit. Should not change the value of that unit. They should not change with time. They must have a fixed value, because suppose 200 years back the value of 1 meter, whatever it would be, if it would not have been same here, then there will be discrepancy in the study. That's why it should not change with time. Clear? So basing on these facts, basing on these points taken into consideration, yes, we have devised a system under which all the physical quantities will be measured. Clear? So there are n number of systems can be devised, but globally we are following one system that is called ASI system. ASI system. Clear? ASI system, it stands for System of International Unit. So the International Association and for your weights and measures, they have named this system to be your SI system. Under your SI system, your fundamental physical quantities can be measured, like suppose fundamental for your mass, the standard unit is 1 kilogram. Now just like your mass, just now I have said, for mass it is 1 kilogram. Similarly for length, so the length is your 1 meter. Yes, 1 meter, it is defined as the distance travelled by light in 1 by 299,792,458 of a second. It is a distance moved within this span. It's a very short span. Within that shortest span, whatever distance is covered by the light, there is your 1 meter. Clear? Similarly, all these physical your standard unit, they have devised or defined. But their definition is quite complicated, but they are not as simple as this too. Yes, 1 kilogram is what? It is measured like this. One alloy is taken, platinum and iridium, with definite proportion. Yes, see, and from that material a very small portion of a particular dimension, yes, what I perceive that is 2.5 centimeter height and 2.5 centimeter dimension, a cylinder is taken out of that material. Yes, and whatever be the mass contained in that material or that object, which is being cut from that platinum iridium alloy, that mass is called your 1 kilogram. See, these two definitions are simple to understand, that's why I explained. But these are some complicated definitions, because to define this you must have an idea about the entire physics syllabus, so which is not possible now. By the time time passes, you will get to know what is the exact definition of all these physical quantities.